So today we'll prove this theorem about how to compute the absorption probabilities. But first, we'll restate the theorem and then use the restatement of the theorem to compute the ruin probability of the gambler A in the gambler's ruin problem. Okay, we'll first solve the gambler's ruin problem and then prove this theorem. Now, what is the restatement that I was talking about? It's not a restatement, it's just writing this longhand. Instead of writing in this matrix notation, if you just unfold the notation in this matrix, hidden in this matrix notation, what you get is that this is essentially same as writing. For every I in T and for every J in T complement, Uij should be written as a sum of K belonging to T, Qik times Ukj plus Pij. Now note that this first term here is coming from this Qu, and the second term here is coming from this R, and R, ijth element of R is just Pij, because R is just the P restricted to those columns, those rows and columns. Okay, so when I is from T and J is from T complement, those Pijs are contained in R. Okay, again, for same logic, when I and J are both in T, I and K are both in T, Qik is equal to Pik, because restriction of P to the transitions between the states in T is precisely Q. So therefore, Qik, instead of Qik, I can just write Pik. So this relation we are going to call star-star. We are going to prove this relation later. We'll first use this to solve the gambler's ruin problem, as I've already mentioned. And of course, we'll prove this thing. So let's go back to gambler's ruin problem. We had a discussion, we recalled it in the last lecture. So in this case, remember that xn denotes the amount of money A has after n tosses, right? So therefore, x0 is A identically. So this Markov chain starts at A, and the transition matrix is given by this. So this is something we have already discussed. So if you start, your I is one of the interior values, not the value 0 or A plus B, then we'll go to one of the neighbors with probability half. Okay, either we'll move to I plus 1 or I minus 1 with probability half. On the other hand, if I is either 0 or A plus B, one of the terminal values, then will just remain the same. So P00 will be 1 and P A plus B will be 1. And of course, all other transitions have probability 0. Now in this case, S happens to be the 0, 1 all the way up to A plus B, because A can only own this much of money, starting from 0 all the way to A plus B. 0 means A has already ruined, A plus B means A has won the game and B is ruined. We also discussed that the transient states in this case are the states all the way 1 to A plus B minus 1, except the 0 and A plus B, which are both absorbing states and hence recurrent. All except those two, all the other states are actually transient states. Now our tau here is the first time the Markov chain enters the recurrent states. In other words, first time the Markov chain is absorbed in one of the absorbing states. In this case, the recurrent states are just the absorbing states. So either xm gets absorbed in 0 or xm gets absorbed in A plus B. Now, our assumption that tau is finite with probability 1 starting from any I, this is actually true in this case, thanks to the exercise that I gave you. So therefore, we are in the setup where we can actually apply the theorem. So what we want to compute is, we want to compute that starting from A, the Markov chain hits the recurrent states for the first time at 0. That is UA0. This is the probability that A is ruined, because this means A has zero amount of money, and that's where the game is ending and A is ruined. So in this case, it so happens that the recurrent states are only the absorbing states. Therefore, this is also the probability that the Markov chain gets absorbed in 0. X tau is the final value of the Markov chain. Okay. This may not be the case in general, but in this special case, this is indeed the case. What we will actually compute? We will actually compute, starting from any I, what is the chance that A gets ruined. We'll compute that, and in particular, putting I equal to A, we're going to get the answer to the question. And in order to compute these UI zeros, we are actually going to use star star. Okay, so let's now try to see what star star gives us. So if you look at star star, this just gives you that for every I in T, and T in this case is 1 to A plus B minus 1, UI0, by the way, we are only interested in UI0. We don't care about other one. So let's just worry about UI0. So UI0 is sum of QIK times UK0 as K runs over T. T is this set plus PI0. Now what we will do is, for each I in T, instead of writing UI0 every time, we'll just call it UI. Okay? We'll just abbreviate, instead of writing UI0, we'll just write UI. So UI is defined to be UI0. And therefore, this will become, by the way, this QIK is same as PIK, because Q is just restriction of the transition matrix P to the transient states. It's a transition between the transient states. So therefore, this is just PIK. And then, of course, T is 1 to up to A plus B minus 1. So that's where the sum is running. And then UK0 is just UK. And of course, PI0. So now let's try to put I equal to 1 here. If you put I equal to 1, you'll just get this quantity here. Now note that when I is 1, then the only two transitions from 1 are from 1 to 2 with probability half, and from 1 to 0 with probability half. So Pi0 would be half, P10 would be half, and P12 would be half. But note that here we are only considering the transitions to another transient state. We are only considering K from 1 all the way up to A plus B minus 1. So therefore, the only contribution in this sum will come from K equal to 2. So if K is equal to 2, then what we will get is, this is P12 times U2, and P12 is just 0.5. So this entire sum, the only contribution is coming from the case when K equals 2, and therefore we'll get that U1 is 0.5 times U2 plus 0.5. On the other hand, when I is from 2 all the way up to A plus B minus 2, in these two cases, in all of these cases, there will be two transitions that will contribute, namely from I to I plus 1 and I to I minus 1. These are the only two contributions. And both of them happen to be 0.5. So therefore, in this sum, and by the way, here I should have said P10 from 1 to 0, this transition probability is 0.5. But when I is among these, Pi0 would be 0. There will be no contribution from this Pi0. So here P10 contributed 0.5 here. Here there is no contribution. On the other hand, in this sum, there will be two contributions, namely k equal to I minus 1 and k equal to I plus 1. So that will give you 0.5 u of I minus 1 plus 0.5 u of I plus 1 for all these values. By the same logic, the last one, u of a plus b minus 1, would just become 0.5 u of a plus b minus 2. So in this case, only one of the terms will contribute, one of these terms will contribute, and then this probability would be 0. From a plus b plus 1, going to 0 in one step has probability 0. So therefore, only contribution will come from one of the terms here. Okay, so this gives you that star essentially leads to these. So we have obtained this. So by setting ui to be the probability that starting from I, the Markov chain gets absorbed at 0, or this is the probability that starting from I, A will be ruined. Anyway, what we have obtained is we have obtained these three equations. And these many equations. It's not three, there are more equations here. We have seen all these equations. Now the point is that the terminal ones look different than the ones in the middle. So we can resolve that very easily. We'll just define u0 to be 1 and u of a plus b to be 0. And if we do that, we'll just get that for all I, for all the values of I, from 1 all the way up to a plus b minus 1. So these are all the transient states, right? For all transient state I, ui is just 0.5 ui minus 1 plus 0.5 u plus 1. Okay, we have just set u0 to be 1 and u of a plus b to be 0, and then all of them will satisfy this. By the way, u0 is 1 makes sense. So u0, remember ui was the ruin probability of a if a starts from I amount of money. So intuitively, if a starts with 0 amount of money, obviously a has to be ruined with probability 1. A will be ruined in the beginning itself. So therefore, ruin probability of A has to be 1. On the other hand, if A starts with A plus B amount of money, then B has 0 money. So A will be ruined with probability 0 because A wins the game at the beginning itself. So intuitively, this is why you should choose these two. This is the probabilistic interpretation of these two numbers. But these two are actually just numbers that makes each equation go through. And this basically means that 2 times ui is ui minus 1 plus ui plus 1. So therefore, ui minus ui plus 1 is equal to ui minus 1 minus ui. And this is true for all u, for all I, from 1 all the way up to a plus b minus 1. So therefore, what we have shown is that u0 minus u1 is equal to u1 minus u2 all the way up to u of a plus b minus 1 minus u of a plus b. So we have shown that all of these successive differences of the ui's are equal. Now this will help us compute the ruin probability.